25 years ago, there was a big push for the first generation of wind turbines. The life expectancy for these blades is somewhere between 20 to 25 years, meaning that now there's over 720,000 tons of turbine blades scheduled to be decommissioned within the next 5 years. As of now, the majority of these blades are ending up in landfills, which are reaching their capacity and are the least eco-friendly disposal option given that the materials within the blades are not reused. We are Team Bladecycle, and we were tasked by our sponsor, Stewart and Stevenson, to create a more cost-effective and environmentally friendly solution for decommissioning wind turbine blades. After extensive preliminary research, our team determined that transportation incurs a very high economic and environmental cost within the decommissioning process. This is because there's only one blade on each truck, and if the blade is too large, there's additional oversized fees and escort charges. We realized that one of the reasons for these inefficiencies is that the cutting process is not streamlined and does not make the most efficient use of available space. Our team developed an optimization code that is an expanded version of the cutting stock problem. It is a constrained linear integer program that takes inputs such as truck trailer size and blade dimensions to then output where the cuts should be made to maximize packing efficiency within a flatbed truck. This, in turn, will lower cost of transportation by up to 60% and will also lower the environmental impact by having less trucks on the road. Wet wire saws are the best mechanism to execute the cuts on fiberglass blades, given that they can mold to non-uniform cross-sections and make fast and precise cuts. Cut sections of blades can be stacked on a flatbed trailer or further broken down with our hammer mill chipper. The hammer mill chipper we designed has 32 hammers that are evenly spaced by rotor discs. Each hammer spins freely around its outer axis and repeatedly impacts fiberglass from the blade. The machine then outputs small, uniform-sized chunks that are easier to transport and can be used for several recycling processes. As seen in the scaled prototype we created, we were able to compare the difference in space taken up by full wind turbine blades versus the equivalent mass chipped on a truck bed. This also reduces the cost of transportation by eliminating the need for specialized transportation vehicles. Both solutions reduce space in landfills as a worst-case scenario and make it easier to reuse or recycle wind turbine blades. The current global landscape is moving aggressively towards renewable energy, especially wind energy. With more turbines being created, there will be a higher demand for decommissioning and recycling in the future. Our team proposes a first step in optimizing a critical process in renewable energy generation that has been overlooked by the industry.